Hey, Bald Eagles. I'm glad that you are continuing to keep up with your notes. So let's get right into our continued work of solving systems of equations. So far, we've worked with graphing. So far, we've worked with substitution. We've worked with elimination using addition or subtraction. And so today we are continuing elimination, but using multiplication. The examples I give you are going to be some of the more involved examples so that I can help you out with them. When you do your practice, it will be a mix of these type of examples and a few that will be a little bit easier. You know that the basic idea of elimination is to be able to cancel out your x's or cancel out your y's. And once you have solved for the remaining variable, then you can just use substitution to find out what the other one is. But sometimes the equations are not set up so nicely that you can just simply add them or subtract them and move on. But this still ends up being an excellent method for so many of your systems of equations. So we're on Chapter 6, Lesson 4, Elimination Using Multiplication. This is going to need to be on page 124. And just as a matter of keeping up with things, keep in mind these are the notes that I am assigning on Thursday, and they will be checked on Friday. So if you have not done the previous notes of elimination using addition and subtraction, the notes that are due on Thursday, make sure you get this taken care of. And then we have these next notes. Okay, so pause the video if you need, copy the problem, and then we'll take a look. Okay, so for this first problem, we are definitely not ready to start combining these two equations in any way. Because if you look up at the first equation, there's some distributing that needs to be done. Now, I will tell you, we're going to be writing results here, and then we're going to come over and write results here. So basically, don't write really, really big, because we're going to go across the page. So we're going to draw ourselves a little arrow, and we're going to take care of our distributing. So our 3 times 4x, we get a 12x. 3 times y is y, and of course, since it's positive with a negative, I end up writing a minus 3y. And that's equal to our negative 3. This other one, I don't have any fractions, I don't have any distributing, I don't have anything of issue. So I'm just going to bring that over. 6x plus y is equal to 1. Now, if we were doing this by way of substitution, I'd say take the second equation, solve for y, and substitute back into the first equation. But today we are looking specifically at the method of elimination. Now here's the thing. We can choose to eliminate our x's. We can choose to eliminate our y's. It's really not going to matter. The choice I'm going to make for this particular problem is to eliminate the y's, because I notice that in this case, I already have a negative 3y. If I were to take this y and multiply it by 3, I'd have a 3y. And negative 3y plus 3y is going to cancel out. So here's what we need to do. We're going to keep the first equation exactly as is. 12x minus 3y is equal to negative 3. But the second equation, because I want to make this y into a positive 3y, I am going to multiply by 3. So notice if I think of full distributing, if I think of multiplying each and every term, 6x times 3 will give me an 18x. Y times 3 will give me a plus 3y. 1 times 3, so I have equals a 3. Well, now we're back to yesterday. Because you got a negative 3y plus 3y, that guy's going to cancel out. So let's combine. 12x and 18x, that gives me a 30x. My y's, they're gone. Negative 3 plus 3, that happens to equal to 0. That's the only thing on that right-hand side, so make sure you're writing down the 0. If we divide both sides by 30, we end up with x is equal to 0. Now, from this point, we can take whatever equation we want. We can take the first one, we can take the second one. Quite honestly, we could take some of these in the middle. Well, I'm going to take the second one. It looks a little bit easier to work with. So I'm going to take 6x plus y is equal to 1. And since x is equal to 0, in place of x, I'm going to put a 0. So that 0 is the 0 plus my y is equal to 1. Therefore, y equals 1. Now, don't use another line. Just simply over here, show that when x is 0, y is 1. Okay, let's write down the second one. For this one, and instead of having 3 columns, we're going to have 4. So just be aware of that when you're writing. I'm going to pause the video, get the problem ready, and then I'll have you copy it. All right, go ahead and pause the video in order to copy this problem. I would imagine that already when you look at the problem, you notice the fractions. And one of the very first things I notice is I even have mixed numbers. And I definitely don't want to mess with that. So the first thing I'm going to do, I'm just going to take my first equation. I'm going to keep the 1/4 x for now, plus a 4y, and set it equal. 4 times 2 is 8, plus 3 would give me an 11 over 4. So I'm just going to take my 2 3/4, and I'm going to rewrite that as an improper fraction. Same thing down on the second one. So I have a 3x plus a 1/2 y. 4 times 9 is 16 plus 1, so I get a 37 over 4. Okay, so I'm done with my mixed numbers, but I've got fractions. I don't want to mess with fractions, so I'm going to get rid of them. The first equation, I'm going to multiply by 4. So that's 1/4 times 4. I'm just looking at an x. 4y times 4, so that's a plus 16y. And 11 over 4 times 4, so that's equal to 11. On the next one, I have a denominator of 2, a denominator of 4. Least common denominator here is 4. So that would give me 3x times 4, that's a 12x. 1/2 of 4 will give me a plus 2y. And 37 over 4 times 4 will give me a 37. Okay, so now I have a much more reasonable problem. We had mixed numbers, we got rid of them. We had fractions, we got rid of them. Some of you are looking at the fact I did this middle step and you're thinking, why did I bother doing that? Couldn't I have just gone from here to here? If you're careful, yes you can. Be careful. Okay, now for our new method of elimination. Again, it's not going to matter whether we choose to eliminate the x or to eliminate the y first. If I choose to eliminate the x, the key thing is going to be multiplying the numerator by 12, or the first equation that is by 12, and then making sure we have different signs. If I choose to eliminate the y, if I look at 16 and I look at 2, I know that if I take that 2 and multiply it by 8, I'd get a 16. Again, I'd want to pay attention to my signs though. Well, I'm going to work on getting rid of my y's. It doesn't matter whether it's x or y, it's just whichever one you feel like, in all honesty. So, the first equation I'm going to keep as is. I'm going to have my x plus 16y is equal to 11. The second equation, if I multiply by 8, my 2y becomes a 16y. Okay, that's pretty good. But I actually have to multiply by a negative 8. This is always what I'm multiplying by. What you multiply by on one side, you multiply on the other. We're not doing adding or subtracting. Okay, so now let's distribute. 12 times the negative 8 gives me a negative 96x. 2y with negative 8, so I write a minus 16y equals 37 times negative 8. If you work that out, feel free to use your calculator. You should have a negative 296. All right. From here, we combine. A single x, so 1 and negative 96, will give me negative 95x. My y's are gone, just like they should be. 11 and negative 296. In your calculator, you can enter 11 minus 296. You can think through different signs, subtract, take the sign of the larger. We get a negative 285. Next, divide both sides by negative 95. You're going to get x is equal to 3. Okay, from here, we take any one of these equations we want. Now, we could work over here, but quite honestly, if we did that, we'd have some fractions. How about we come way over here? X plus 16y equals 11. That's a pretty easy equation we can work with. So I'm going to write that down. Then I'm going to use x plus 16y equals 11. Where I have an x, I'm going to substitute my 3. So 3 plus 16y is equal to 11. We'll subtract a 3 from both sides, giving 16y is equal to 8. And if you divide both sides by 16, you're going to get that y is equal to 1/2. So, when x is 3, y is 1/2. This would have been horrible to try to graph, try to use substitution, anything like that. Elimination, you're able to bring these equations down to something much cleaner, much easier to work with. Okay, I'm going to pause the video so I can write the last equation. Okay, this one is going to take 4 columns again, just like number 2. So what I want you to do is first show your first new system of equations where you have changed your mixed numbers into impropers and where you take care of the distributing the 1/2. So pause the video, do that part, and then we'll check. Okay, so check your work. Make sure the 24 1/5 became 121 over 5. Make sure 3 over 3.5 became 7 over 2. Make sure you're distributing. Gave you a 3x plus 1/2 y. Next, look at the first equation. Think of what we're going to multiply by to get rid of our denominator. That should be a 5. Look at the second equation. Notice in that case, you need to multiply by a 2. All right, pause the video, do that step. All right, so check your work. Now, so far we've been getting rid of the y's. I want to make sure that you recognize that it doesn't have to be that way. So in this one, when I look at my 2 and I look at my 6, my 2x and my 6x, I'm going to decide to get rid of my x's. Now if I take my 2x and I multiply by 3, 2x times 3 will give me a 6x. Okay, so that's sounding pretty good. But if I have a 6x up here, then down here I would need to have a negative 6x. So I'm going to take the second equation and multiply by negative 1. But if you're thinking, oh, wait a minute, couldn't I have just taken the first equation and multiplied by negative 3? Yes, your choice. But for notes, this is how I'm going to set it up. So what I want you to do is come up with this next system of equations, and then I want you out of that to solve for y. So pause the video and we'll take a look. Okay, so check your work. Make sure here you did multiply each and every term by 3. Over here, make sure you multiplied each and every term by negative 1. Make sure that you combined correctly. 90y minus y is an 89y. You divided both sides by 89, and you got y equals 4. I'm going to choose this equation right here, 6x plus y. So pause the video, substitute 4 into that equation, and then we'll check work. Okay, check your work. Now